Hello friends, as if we have discussed in the last video regarding insertion sort as well as the analysis of insertion sort. The next different sorting technique which belongs to a sorting technique which is again quite easy and simple, named as selection sort. In this video I am going to explain you about how selection sort works, what are the various characteristics of selection sort, advantages of selection sort or sorting algorithms, and disadvantages of sorting algorithms. In the next video, I am going to explain you about the analysis of selection sort. These are the contents for this today's video, where first is the description. What is selection sort? Selection sort is this sorting algorithm is an in-place comparison based algorithm in which the list is divided into two parts at the left end, and the sorted will be at the left end and unsorted part will be at the right end. In other words, it is also called as comparison based algorithm. The sorted part is empty and the unsorted part is the entire list. The smallest element is selected from the unsorted array and swapped it with the leftmost element. If we are sorting the whole list of elements in the ascending order, as we know that the ascending order is the way of order in which on the left hand side there are the smallest element, whereas on the right hand side there are the largest element. Smallest to largest. That element becomes a part of the sorted array. This process continues moving unsorted array a boundary by one element to the right, whereas this particular algorithm is having again certain drawback, which is not suitable for large amount of data set, as its average and worst case complexities are both order of n square, where n is the number of atoms or number of elements. As I have already discussed, the smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes the part of the sorted array now. After sorting first, there is no any need to compare again with that particular position, cause it is already in a sorted with whole list of element. This process continues moving unsorted boundary by one element to the right, each time selecting an element according to its ordering and placing it in the correct position in the sequence. With the next example, you may definitely able to know how the sorting works. For each index position I, find the smallest data value in the array from position I through length -1, whatever that length -1, where the length of the data or length is the number of data values which are stored already in the list or in the given list. The time complexity for the average case and best case time complexity for selection sort is order of n square, whereas space complexity for the selection sort is order of 1. In the selection sort technique, the list is divided into two parts. In one part, all elements are in sorted, and another part, all elements are unsorted. As we first take the maximum or minimum data from the array, as I have already said, it depends up to you. If you are taking the minimum data from the array, you have to keep it with on the left hand side. If you are taking maximum data from the array, you have to keep it with on the right hand side. After performing, the array is getting smaller, thus this sorting technique is simply get done. There are these 5 different steps or this algorithm which is given over here is very simple, very easy and very genuine. First is set minimum to the location 0. Search step number 2. Search whatever the minimum element in the list, we have to find that element. If you are unable to find whichever is the minimum, then this selection sort may not work. We have to select the minimum element or the smallest element from the given list of array, from the given list of elements or from the array. After selecting that particular value, you have to keep, or you have to swap that particular value with the very first location, whatever that position it may be, whatever that value it may be. Swap it with the location which is minimum. Ultimately, this is nothing but the first location, or we can say that 0th location. Increment, after that it automatically sets your very first position, that is whatever that minimum value, it automatically sets. After that, increment that minimum value to the next element. It directly means that no need to disturb the very first position in that given list, because this is already sorted. Repeat the whole algorithm unless and until the complete list is sorted. If you have find that your whole list is sorted, definitely you have to stop the algorithm. With the help of particular example, now I am going to explain you how selection sort works. This is the complete unsorted list where 5, 2, 1, 4, 3 are given. First iteration, we have to compare the 5 with whatever the smallest element you have. In the given list, we definitely find to know that 1 is the smallest element. Compare with each and every element in the list. Smallest is equal to 5, 2 is less than 5, that's why smallest is 2, 1 is less than 2, that's why smallest is 1, 4 is greater than 1, smallest is 1, 3 is greater than 1, smallest is again 1. Definitely we have to swap 1 with 5. The whole process we have to do it unless and until you may get the complete list in a sorted order. If I am going to swap 1 with 5, my list will become like this: 1, 2, 5, 4, 3. Rest of the elements are not get sorted. Second iteration, which is the very smallest element over here? 2. First is the element number 1 is already in its appropriate position. Now we can compare 2 with 5, smallest is 2, 2 with 4, smallest is 2, 2 with 3, smallest is 3. Then there 2 is already in its appropriate position, no need to swap. Now we can say that 1 and 2 are already in sorted order. Now next iteration, that is third iteration, I can say that 3 is the smallest value in the given list. Compare 3 with 5, compare 3 with 4 and compare 3 with 5. Now after comparing with 3 and 4, we came to know that 5 is in the position of 3. Definitely, to give the appropriate position to the element number 3, we need to swap 3 with 5. If we swap 3 with 5, we may get the following list, that is 1, 2, 3, 4 and 5. After that, there is no any need to swap the other elements, cause 4 is already in its appropriate position. We have to simply check that 4 with 5, compare 4 with 5. Definitely 4 is smaller than 5, so the in the given list or in the list 4 may occur before 5. 4 may occur before 5. That's why there is no any need to swap the given elements. Finally, the sorted list is like this: 1, 2, 3, 4 and 5. This is the pictorial representation in one complete pass or one iteration or in one slide. N number of 5 different iterations are there. Likewise, the sorting is there. As I already said that the time complexity with respect to selection sort, the best case time complexity or best case performance is like order of n square. Worst case performance is like order of n square again, and average case again it is n square. Definitely this particular sorting technique is efficient and effective. There are certain advantages and disadvantages of selection sort. The main advantage of selection sort is that it performs well on small amount of list. If your list of elements or array is quite small, definitely we can use selection sort for sorting the given list of elements. Again, second advantage for selection sort is there is no any additional temporary storage is required. That's why the memory required over here is very less. So the space complexity for the given selection sort is, for the selection sort the space complexity is very less. We can say that order of 1. Whatever that number of elements, it requires only that amount of space to store a particular element with respect to selection sort. There are certain disadvantages for selection sort. They are the primary disadvantage of selection sort is its poor efficiency. We cannot say that selection sort is exactly that much efficient with respect to quick sort or with respect to merge sort. That's why it is not applicable with large amount of data. It is applicable on small amount of data as well only. This is the major disadvantage. And efficiency when dealing with a huge list of elements, as I already said, whereas the selection sort requires n squared number of steps for sorting n elements. As we know that the time complexity in average case, the time complexity in worst case, as well as the time complexity in best case, it is order of n square. So these are the two advantages and two disadvantages of selection sort. Thank you for patience hearing.